Okay, let's continue. Examples. So an example is, let 2 times x minus 3 equals 7 for some rational x. Then what is x? So we have 2 times x minus 3 equals 7. Hence x minus 3 equals 7 by 2, right? By the definition of 7 by 2. X minus 3 equals 7 by 2. Hence adding 3 both sides, x equals 3 plus 7 by 2. That is x equals 13 by 2. So this is one way to solve the problem. Another solution for this simple problem is, so we have 2 times x minus 3 equals 7, right? Hence 2x minus 6 equals 7. Hence, so adding 6 both sides, we have 2 times x equals 13. Hence, by the definition of 13 by 2, x equals 13 by 2. So this is another way to solve the same problem. 2 times x minus 3 equals 7 for some rational x, and we could find the value of x from this equation. Okay. And another simple example. So 3 by 4 by 5 by 7. What is 3 by 4 by 5 by 7? 3 by 4 by 5 by 7 is the multiplicative inverse of 5 by 7 times 3 by 4. And the multiplicative inverse of 5 by 7 is 7 by 5. So the answer is 7 by 5 times 3 by 4 equals 21 by 20. So 3 by 4 by 5 by 7. The ratio of these two rational numbers is 21 by 20. Another example. Let 3 by x minus 1 equals 2 for some rational x. Then what is x? So we have this equation 3 times. We have 3 by x minus 1 equals 2. So this is same as saying x minus 1 inverse, the multiplicative inverse of x minus 1 times 3 equals 2. So this is, both equations are same assuming x is not equal to 1. And so this equation can be written as 3 equals 2 times x minus 1. So to get from one side to another, to get from here to here, you multiply by x minus 1. To get from here to here, you multiply by x minus 1, the multiplicative inverse of x minus 1. So both equations are same. If you are given 3 equals to 2 times x minus 1, we can multiply, assuming x is not equal to 1, we can multiply by x multiplicative inverse of x minus 1 to get the above equation, x minus 1, the multiplicative inverse of x minus 1 times 3 equals 2. And if we are given multiplicative inverse of x minus 1 times 3 equals 2, we can multiply by x minus 1 to get 3 equals 2 times x minus 1. So we can go from one equation to another. Hence these equations are equivalent, assuming x is not equal to 1. And then this equation can be written as 3 equals 2x minus 2, and then it can be written as 3 plus 2 equals 2x, right? So to go from this equation to this equation, we add 2 to get to this equation, and we add minus 2 to get to the above equation. So we can go from one equation to another. So sorry, this is for this holds, and even this holds. So we can rewrite this as x equals 5 by 2. Hence 3 by x minus 1 equals 2 if and only if. So the equation 3 by x minus 1 equals 2 is same as the equation x equals 5 by 2. Hence x is 5 by 2. Hence x equals 5 by 2. Right? Okay. So another example. Let 4 plus x by half of x equals 5 for some rational x. What is x? So we have 4 plus x by half of x equals 5. So we can rewrite this as half of x. So we assumed x is not equal to minus 1, and in the equivalence, at the end of the equivalence, we got x equals 5 by 2. So especially that's not equal to 1. So the equivalences all hold, so to speak. Okay, so we'll just ignore those kinds of things. Fine. 4 plus x by half of x is 5. This can be rewritten as multiplicative inverse of half of x times 4 plus x equals 5. So this can be rewritten as, so what's the multiplicative inverse of so we don't need to expand the multiplicative inverse. Multiplying by half x both sides, we get 4 plus x equals 5 times half x. So both equations are same. So here we should be actually writing, assuming x is not equal to 0. We can consider this equivalence. Then this equation can be written as 2 times 4 plus x equals 5x. So this is same as saying 8 plus 2x equals 5x. This is same as saying x equals 8 by 3. Hence x equals 8 by 3. So this is simple. We are just multiplying by the equations by appropriate terms to simplify the equation, and right. So another example. Let x, y be rationals. Show that 1 by x minus y plus 1 by x plus y equals 2x by x square minus y square. So here we implicitly assume x minus y is non-zero and x plus y is non-zero. Okay, so the answer is, see, 1 by x minus y plus 1 by x plus y, we can make sure they have the same denominator. So x plus y times 1 by x plus y times x minus y plus x minus y times x plus y by x minus y times 1. Now they have the same denominator. The denominator is x square minus y square, and the numerator is, so sum of the numerators is 2x. Hence 1 by x minus y plus 1 by x plus y equals 2x by x square minus y square. Okay. So another simple example. Let 3x plus 1 by 2x minus 5 equals 4 for some rational x. Now what is x? So supposing 2x minus 5 is not equal to 0, that is x is not equal to 5 by 2, the equation is three x plus 1 equals 4 times 2x minus 5, that is 3x plus 1 equals 8x minus 20. Hence 5x equals 21, right? That is x equals 21 by 5. Hence x equals 21 by 5. So it's the same thing. We multiply by appropriate terms to simplify the equation. We multiply by 2x minus 5 both sides to get this simpler equation. 3x plus 1 equals 4 times 2x minus 5, and then we simplify. Okay. So another example. Suppose a car has traveled 5 miles in time half an hour. What is the average speed of the car? So we see that average speed is roughly distance traveled per unit time, right? This is roughly distance traveled per unit time. So average speed equals distance traveled by time taken. Time, that is, average speed is distance traveled by time taken. Hence, so average speed here is, the car has traveled 5 miles. So 5 miles by half an hour. So distance traveled by time taken is, so 5 by half is, so multiplicative inverse of half times 5 miles per hour. So this is 2 times 5 miles per hour equals 10 miles per hour. So the average speed of the car is 10 miles per hour. Intuitively that is clear, right? If it travels 5 miles in half an hour, it travels 10 miles in 1 hour, roughly speaking. And hence the average speed is 10 miles per hour. The distance it travels per hour is 10 miles. Okay. So this is a basic example. Here's a somewhat more interesting example. So yeah, there are a couple of interesting examples. A person takes a trip and drives 8 hours, a distance of 400 miles. His average speed is 60 mph, miles per hour on the freeway, and 30 miles per hour, somewhat lesser, when he drives through the towns. How long did the person drive through the towns during his trip? So a person takes a trip and drives for 8 hours and travels a total distance of 400 miles. His average speed on the freeway is 60 miles per hour, and average speed when driving through towns is 30 miles per hour. How long did the person drive through the towns during his trip? So we can imagine, so the person is driving, it need not be a straight path. He's driving in some path, and for some region you have, so the shaded region, let's say these are the towns, and the normal region, let's say this is the freeway. So a person is traveling, so total distance, so in towns, average speed in towns is 30 mile per hour, average speed in freeway is 60 mile per hour. The total duration is 8 hours and total distance is 400 miles. So we want to find how long did the person drive to the towns during this trip. So we want to find T towns. The time in hours, the person drove through the towns. From the average speeds, so first note that, so T towns is time he drove through towns, and 8 minus T towns, the total duration is 8 hours, right? So 8 minus T towns is the time he drove through freeway. Now we also have the average speeds, right? So from the average speeds, we have 60 miles per hour, and wait, and we can here itself we can write, and so through the towns, when driving through the towns, his average speed is 30 miles per hour. So 30 times t towns is the distance he drove through towns, and 60 miles per hour is the average speed on the freeway, right? So 60 times 8 minus t towns is the distance he drove through freeway. So note that these quantities are the times and distances he drove through the towns and freeway. Now the total distance is 400 miles. We haven't used that anywhere. The total distance he traveled note that the total distance traveled is 400 miles. Hence 30 times t towns plus 60 times 8 minus t towns equals 400. That is, so 480 minus 30 times t towns equals 400. That is, t towns equals 80 by 30, which is 8 by 3. Hence, so t towns is in hours, right? Hence he drove for t towns equals, or I'll just write 8 by 3 hours. Hence he drove for 8 by 3 hours through the towns. So what did we do? We wanted to find t towns, the time in hours the person drove through the towns. Then assuming t towns as a variable, we noted that t towns is the time he drove through the towns, 8 minus t towns is the time he drove through the freeway, and 30 times, and what are the distances he drove? 30 times t towns, because 30 is the average speed through when driving through towns. 30 times t towns is the distance he drove through the towns, and 60 times 8 minus t towns is the distance he drove through the freeway. So this is because, so these are because distance traveled equals average speed times time taken. So 30 times t towns is the distance he drove through the towns, and 60 times 8 minus t towns is the distance he drove through the freeway. But these distances he drove should add up to the total given distance of 400 miles. Hence 30 times t towns plus 60 times 8 minus t towns is 400, and solving this we get t towns is 8 by 3. Hence he drove for 8 by 3 hours through the towns. Okay, so this is a somewhat interesting example. Another example, let x be a rational number. So now what is 1 plus x squared plus so on till x power n? What is the sum of these powers? So we let s equal, we want s equal to, so this is defined to be 1 plus x squared plus so on till x power n. Note that x times s is x plus x squared plus x cube plus so on till x power n plus 1, or we can write x cube plus so on till x power n plus 1. Now subtracting first equation from second equation, so xs minus s is, so x power n plus 1 minus 1, right? Because so if we write even the preliminary term plus x power n plus, so these terms sort of match, and when we subtract the first equation from second equation, on the right hand side we get x power n plus 1 minus 1, and the left hand side we get xs minus s. Xs minus s is x power n plus 1 minus 1, that is x minus 1 times s equals x power n plus 1 minus 1. Suppose x is not equal to 1, then we can divide by x minus 1 and write x power n s equals x power n plus 1 minus 1 by x minus 1. Hence s equals x power n plus 1 minus 1 by x minus 1 if x is not equal to 1, and if x equals 1, s is just 1 plus 1 plus 1 so on till n plus 1 times. If x is 1, then s is 1 plus 1 plus 1 so on till n plus 1 times. Hence s is this, that is 1 plus x squared plus so on till x power n. This is x power n plus 1 minus 1 by x minus 1 if x is not equal to 1, and n plus 1 if x equals 1. This is the simplification of the sum of these powers. So what did we do? We just took, so we want s equals 1 plus x squared plus so on till x power n. We observed that if we multiply s by x, we get x plus x squared plus so on till x power n plus x power n minus 1. Then so subtracting one equation from the other, we see that many of the terms cancel out, and we get xs minus s is x power n plus 1 minus 1. So when x is not equal to 1, we can further simplify this as s is equal to x power n plus 1 minus 1 by x minus 1. Hence we get the explicit expression for s in both cases, when x is not equal to 1 and when x is equal to 1. So this is the expression, right? So this is one example, and we look at another example. The radiator of a car contains 8 quarts of liquid consisting of 60% water and 40% antifreeze. How much should be drained and replaced by antifreeze. If the resultant mixture should have 10% water and 90% antifreeze. So the radiator of a car consists of 8 quarts of liquid, and in that 8 quarts 60% is water and 40% is antifreeze. So let's describe the problem. We have 8 quarts, so 60% water and 40% antifreeze. So we want to remove X quarts and replace with X quarts of antifreeze. And we'll again get 8 quarts of liquid, but we want the final composition to be 10% water and 90% antifreeze. We want X such that above picture holds. So let's see. We begin with 8 quarts. Of this, 60 by 100 times 8 quarts is water and 40 by 100, so 40% of it is antifreeze. So first we remove X quarts of the mixture, then we get 8 minus X quarts, right? 8 minus X quarts, and of that the composition will remain the same. 60% will be, so it's the same liquid but that quantity has reduced. 60% of 8 minus X quarts water and 40% of 8 minus X quarts antifreeze. Now after removing 8 quarts of the mixture, we are add X quarts of antifreeze. Then we get, so the question is this, right? How much should be drained and replaced by antifreeze if the resultant mixture should have 10% water and 90% antifreeze? So we want to find how much we must remove X. So we have removed X quarts of the mixture and added X quarts of antifreeze. Then we get 8 quarts of liquid again, back to 8 quarts of liquid, but now this will be 60 by 100 times 8 minus X quarts water, and this will be 40 by 100 times 8 minus X plus X, these many quarts of antifreeze. So we want the resultant composition. We want resultant composition to be 10% water and 90% antifreeze. That is, so we want this 40 by 100 times 8 minus X plus x divided by the total volume 8. This is 90 by 100. So these percentages, by the way, the question should mention, although Lang doesn't mention it, but it should mention by volume, such that this mixture is this by volume. So the percentages are all by volume, not by weights or anything. So we want this percentage by volume. So 40 by 100 times 8 minus x plus x is the resultant volume of antifreeze, and 8 is the total volume of the mixture in the end. And so this is volume of antifreeze at the end. So this is volume of mixture at the end. So we want this ratio to be 90 by 100. Hence we can simplify this, right? 0.4, we can write the fractions in terms of decimals. 0.4 times 8 minus x plus x equals 8 times 0.9, that is 3.2 plus 0.6x equals 7.2, that is, so 0.6x equals 4. Hence x equals 4 by 0.6. So 0.6 is just shorthand for 6 by 10. So this is 6. So this is multiplicative inverse of 6 by 10. This is 10 by 6 times 4. This is equal to 2 2s are 4, 2 3s are 6. This is 20 by 3. Hence we need to replace. We can further simplify 20 by 3 in better terms. This is equal to 6 plus 2 by 3, right? 20 by 3 is 6 plus 2 by 3. 6 3s are 8. So 20 is 3 times 6 plus 2. Hence this 20 by 3 is 6 plus 2 by 3. Hence we need to replace 6 2 by 3 quarts of the mixture with antifreeze to get the resultant composition. So if we start with the 60-40 by volume mixture of water and antifreeze and remove 6 2 by 3 quarts from these 8 quarts and replace it with antifreeze, remove 6 2 by 3 quarts of the mixture and replace it with 6 2 by 3 quarts of antifreeze, then we get a resultant mixture of composition 10% water and 90% antifreeze. So this is one interesting example. We removed x quarts of the mixture and added x quarts of the antifreeze and found the resultant composition in terms of x, and we want the resultant composition to be such that this 90% thing holds, and from that we get x. So right, that's all for this part. See you in the next part.